Question 1. So I'm just opening. So the strategy here is the whole course open, of course, the revised one. So it starts with sets, it goes on to functions. So we'll be skipping every so question 1, we are skipping that part because it's about circle. The same with question 1, A1 and A2, B matrices, the whole B, C matrices, so we skip the whole of that. So go to question 2. I hope you all have a question. Question 2A, A1. Simplify the set B minus A intersection C complement complement. Okay, so given that all the sets A, B, and C intersect, you want to simplify. So how far do you go? First thing is you change the minus. Follow the steps. You don't bring the complement outside before changing the minus. So first you change the minus. So go in the brackets and make it B intersection A complement intersection C complement and then complement. Then we now go inside the brackets and take the complement that is from outside. So we're taking the complement from outside inside. So we're going to have B intersection A complement complement union. It will affect the intersection union C because of the two complements there. And this, we now take the complement outside inside. So it will be B complement union A and then union C. So can you simplify further? No? Because we have different sets there. So we go straight to another part. So you follow the step. First, the minus, the complement outside, and then the complement again outside the brackets. Then you're done. 2, given that set A is equal to negative 2, 6, B is equal to negative 5, 3, C is equal to negative 1, 8, and the universal is equal to negative 10, 10. Now you are seeing this. Then when you see it in the sports hall, yeah. Okay. Okay, so first again, we take the complement inside. So it will be B intersection C complement. So whenever a complement finds a complement, the complement part goes. So we have A, we have B, but we don't have C complement because our new set now is this one. So we must have all those components of that set inside there. So we go to C and get C complement. C complement is everything that is not in C, but in the universal. The universal is negative 10 to 10. So C has from negative 1 to 8. So it leaves out negative 10 to negative 1 open, union, 8 open, 10 closed. So this makes the complement. So now we come to A union B intersection C complement. So A is -2, 6, and it will be waiting there. So now we'll get B and take it here, -5, 3, intersect it, -10, -1, union 8, 10, like that. So the intersection here is the intersection of these two sets. Now, if you draw a number line, you have -10 to -1. Open there, closed here. This is part of C complement. You also have 8, not included, all the way up to 10, included. That is C complement. Then you bring in B, that is -5 to 3, open. Okay, so the intersection here, you see that there will be nothing from the right of 3 there. The intersection will be here. This is where these two will intersect. And that part is -5 not included, up to -1 excluded again. So you get that part and bring it to A, -5, -1. So you want the union. So the union here is from -5, you come all the way to -2, and then you want to end at -1, but this guy takes up everything all the way up to 6. So to be the union. And you can try the number line. If you came here with the -2, it would be here, and then you go up to 6, somewhere there. So it will be there. So it's going there. So when this guy starts from -5, we shed, you go all the way up to -1. Then the other one now will continue, takes it all the way up to 6. And since it's union, it's plus, so don't subtract anything. That's why you have picked the whole set there, from -5 to the other piece.
So,
Like that. Hello.
since our universal is not a set of real numbers, why are we considering the boundary numbers
Is it not?
even if we are considering them?
Have I read it well? Our universe is a set of real numbers. It's from -10 to 10. And no set has been mentioned, meaning that it's real numbers. The one that takes the whole interval.
Also, if they've just given a range, meaning they're still real numbers,
Yes. So if
unless
there
they
was a difference,
specify.
they would have specified to say integers, natural numbers, what, and they cannot give them an interval form like that. Only real numbers takes the interval. Okay. Then B, express 2.534 bar in the form P over Q, where P and Q are integers and Q is non-zero in its lowest term. So you say, let X be 2.534 bar. And then the first thing you do is to move this 5 to the left by multiplying every side by 10. So that you remain with the numbers under the bar. So if there are n numbers under the bar, you count them. How many? If it's 1, you multiply by 10. If it's 2, by 100. If it's 3, by 1,000. Both sides. After that, you come back, okay? You call this equation 1 and count now the numbers under the bar. How many numbers are under the bar? If there are 2 in this case, you multiply equation 1 by 10, by 100. So I'll multiply 10x by 100. It will be 1000x. And then on the right, 2534.34 bar. And I'll call it equation 2. Then I'll now subtract equation 2 minus equation 1. Both sides. So 1000 minus 10, you get 990 x. And then this must be equal to, we subtract also on the right, after showing it on the number line, then you write it. Not just showing it on the number and don't write it. That's not okay. So we now subtract 2534.34 bar minus 25.34 bar. So we have 0 there, and here 2, 1. 5 from 14, we get 9, and then 0 there, then 5, 2. So we have 2509. Then you divide by 990, you divide by 990. So x becomes 2509 over 990. So I now leave it for you to see if there's a number that can reduce there. Of course, you can try 3 and 9 because of the 9 that is there. Okay. That was just a revision. I know you know that part very well. You've been doing it for some time now. Now you have this number here, minus 1 squared. Write in terms of p plus q root 3. Write it in terms of p plus q root 3. What do you do? When there's a square, your first thing is to square the number. Simple. The square means you multiply the number by itself. Don't start rationalizing here. It is a square. X squared means x times x. So that thing squared means that thing by itself. So you have 3 plus root 3 over 3, root 3 times root 3, you get 3, and then minus root 3, minus root 3, then plus 1. When you're multiplying this, nothing cancels. We are squaring. Don't even expect that something will cancel or make that mistake, no? Then now you have 3 plus root 3 over 3 plus 1, you get 4, minus 2 root 3. Then this becomes 3 now, root 3. You now rationalize. What do you rationalize? The denominator plus, and also multiply by the same thing down. Like that. And then you say 3 times 4, 12. 3 times 2, 6 root 3. Root 3 times 4, 4 root 3. And 2 root 3 times root 3. Root 3 times root 3 is 3. Then 3 times 2. This 2 will give you 6. Then you divide by 4 times 4, 16, plus 8 root 3 minus 8 root 3 minus 2 times 2, you get 4. Root 3 times root 3, you get 3. So don't multiply, don't forget to multiply everything there. So on top we'll have 12 plus 6, 18 plus 6 plus 4. We have 10 root 3 over 16 minus 12, because this will be 12 here. So 16 minus 12, we get 4. So it becomes 18 over 4 plus 10 over 4 root 3. In terms of P plus Q, we're already there. So we just simplify. 2 in 18, it goes 9 times, and 2 in 4 goes twice. 2 in 10, 5, and 2 in 4, 2, and then root 3. Okay. Okay, then we go to the next one, the third one. Given that 1 minus 2i over z is equal to 2 plus 5i, write z in terms of, find z in the form a plus ib, where a and b are real numbers. This question is the simplest question ever, if you understand it. The biggest mistake you can make is trying to change z where it is here and write it as a plus bi, and then start cross multiplying and solve simultaneous equation. That one, it becomes long. You can get to the answer, but you can waste a lot of time. So the best you do is, just at this point, you cross multiply. So it becomes 1 minus 2i is equal to 2 plus 5i z. And then divide by 2 plus 5i. Divide by 2 plus 5i. So this one and this one will cancel. So you remain with z is equal to 1 minus 2i over 2 plus 5i. It has now become a normal complex number. So you conjugate it. You multiply 2 minus 5i, 2 minus 5i. So 1 times 2, you get 2 minus 5i minus 4i, and then plus 2 times 5, 10 I squared, so that it becomes negative 10. So you say this is the same as negative 10 over 2 times 2, 4, minus 10i plus 10i, 5 times 5, 25, plus times negative, negative 25, I times I, negative. Negative times negative 25 becomes positive 25. Then now you have 2 minus 10, you have minus 8, minus 9i over 29. So you can now write that as negative 8 over 29 minus 9 over 29i. As simple as that. This is in the form a plus bi, because there's a real part and the imaginary part. So we go to C. C1. Let star be a binary operation on the set of real numbers defined by A star B is equal to AB minus A plus B. Determine whether the binary operation star is commutative. To check commutativity, you must show that A star B is equal to B star A. Is that true? We check. So you start with B star A. which you don't know, because A star B is already given. So you check for B star A. So B star A is going to be B multiplied by A minus B plus A. But this is the same as AB minus A plus B, which is A star B. Hence, commutative. These are the easy questions that even if you are tired, when you see it, you become very much active. Now, using the definition of the operation in part 1, evaluate 2 star 3 star 4. Now you have seen that the operation is only defined in 2 pieces. So you pick first the brackets. You say, what is 3 star 4? It's going to be 3 by 4 minus 3 plus 4. 3 by 4, that is 12, minus 3 plus 4, that is 7. So you get 5. Then you come back. Now you're going to have this star 5, which is going to be 2 multiplied by 5 minus 2 plus 5. So you have 10 minus 7, which is equal to 3. Very small numbers, so no complications. It's really nice when it's binary. The third piece, you are given functions f of x is equal to 2x minus 3. You're also given g of x is equal to x plus 1 over 2x. Find f of g inverse and state the domain and the range. So the easiest here is you let this be y, and then you solve for x to find the f inverse. So we're going to have y plus 3 is equal to 2x divided by 2 divided by 2. So x is y plus 3 over 2, which becomes f inverse. How do you get the inverse? Which becomes f inverse of x, which is x plus 3 over 2. Okay, you also come there and let this to be that over 2x. Cross multiply again, we have 2xy is equal to x plus y. Bring this x here, we have 2xy minus x is equal to 1. Factor out x, we have 2y minus 1 is 1. Then solve for x, you get 1 over 2y minus 1. So that you have g inverse of x is equal to 1 over 2x minus 1, provided x is not equal to half. Okay. Then now, the question says, find f of g inverse. Now, f of g inverse is the same as g inverse of f inverse. So, g inverse is here. So, in g inverse, where there is x, we'll take f inverse and then minus 1, meaning that we have 1 over 2. F inverse is x plus 3 over 2 and then minus 1. This becomes 1 over x plus 3 minus 1, because these 2 and these 2 cancel. So we'll have 1 over x plus 2. And what is the domain here? You say the domain of this is x such that x is not equal to negative 2, but x is all real. Okay? To find its range,
So,
hello.
what if you started with the G outside here? The F outside, I mean.
Here,
Still the same?
no, it's completely different.
I mean, writing them, like starting with the F, and then the G, putting it inside.
It will be wrong. This is not the same as this. These are different. They are very much different.
So,
Hello.
so if the question was G of F inverse, we're supposed to write the reverse.
Yes.
Okay.
Now to
But
find
it's still okay. It's still okay even to use this, like finding first the G of F, then you find the inverse of that. Isn't it?
not G of F. Unless you
No,
find first
F of
F of
G.
G. Yes, but how do you
Yes.
find the domain?
Then afterwards you find the separate the inverse for, I don't know whether it's for G and the inverse for the other.
Because the mistake you make is you find this, then you find its inverse, then you want to find the domain. You just get the domain of the answer. Sometimes you get the domain of G inverse when the inner function is F inverse. So this is why I define it like this, so that we're able to see which function is inside. That's the reason why I'm forcing you to use this, because it will tell you that it's not G which is inside, but F inverse. So that as you find those inverses, you'll find them for a purpose. Then to find the range of the inverse, you will now find F of G of X, which is in 2, where there is X in G, you bring in a G, which becomes this 2 and this 2 will go. So we'll have X plus 1 over X minus 3, which is the same as X plus 1 minus 3X over X, which is 1 minus 2X over X. Then the range now of F of G inverse of X is Y. So now I get the domain of this. The domain of this is X not equal to 0, but X a real number. Then you change the X, it becomes Y. So Y not equal to 0, but Y a real number. This is the range of the F of G inverse. The domain of the original F of G is what gives you the range of the R.
So when finding the domain, it's better to use this one here. Rearranging the F of G, then finding the range, you just solve it direct.
To find the range, you
And
solve it
finding the
direct.
F of...
Yes.
Sir,
Yeah. Hello.
I've forgotten what you said last time about what's this, on how to find the domain of a composite functions. You were saying something about inverse, shan. So I'm kind of asking if you can repeat what you said last time.
I think I've forgotten.
Oh, okay.
Okay, we don't have time. Let's log out and log back. I'll be able to say it in the next session.